R3 is on solving equations and also clearing fractions from equations. So we're going to do some pretty tricky equations today. So it says the problems in the previous section were called expressions. So expressions don't have an equal sign. Whenever you have an equal sign, so like these ones have an equal sign, that means you have to go all the way down until x equals a number. You can't be like, oh, 7x equals 20. Still not done. You would need x equals something, okay? So some of these are not going to be nice. We have fractions that aren't always nice, okay? So there could be a little bit weird. So it says in your math classes at university, you will need to leave answers as exact answers. So you don't want to round them as a decimal. You want to use fractions, pi, square roots, and so on, okay? Unless you're told otherwise. So sometimes I might say round to the nearest tenth, okay? In that case, you're allowed to round. Okay, the reason we do this is because you guys might be the future bridge builders, right? Engineers and so on, and you might need very precise answers. Remind me to show you a PowerPoint of things where people have failed with math in real life. I'll show you that to you at some point. I think I showed you that last year, didn't I? It's pretty funny. All right, so number one, so we have 3 times the quantity of x minus 2 minus 6 is equal to 9. So we know that with equations, like if I had like x plus 6 equals 13, what we're saying is some number added to 6 gives me 13. And in our head, we don't have to do the transition steps. You guys, almost all of you will know that that's going to be 7. Okay? They introduced this topic very, very early now. My son was in first grade last year, but when he was in kindergarten, they did things where they did like heart plus 4 equals 10, and he had to figure out that the heart was 6. Does that make sense?
Yeah.
We all know how to do that. You guys have learned that very, very early. So what we talk about in algebra is transition steps. So like subtracting 6 from both sides to undo the operation. So we're always undoing when we go to the opposite side. So this first one should be 3x minus 6 equals 9. So we distributed. We then combine all like terms on both sides of the equation. So we have this minus 6 minus 6. So we're going to write 3x minus 12 equals 9. Then we do the transition steps. So in geometry, if you still need to write plus 12, that's totally fine. So we get 3x equals 21. So x is equal to 7. Done. So the next one, we have lots of distributive properties, right? So we're going to distribute the 5 in first, and we get 10x minus 15. Then we distribute the negative, which is really a negative 1 in. So we get minus x plus 5 equals, and we distribute the 10 in. So we should have 10x plus 30. We combine our like terms. So we have 10x minus x, so we get 9x. We have negative 15 plus 5, so we get negative 10. So we've now simplified everything on both sides of the equation. Now it's time for those transition steps where we like subtract and add to both sides, okay? So I typically like to get my x to be positive. So what I would probably do is I would subtract 9x from both sides. So that way I have 10x minus 9x, which is 1x, or just x. Okay, but now with the numbers, there's no way to make the numbers, like I don't want to add the 10 over because then I have everything, like x's and numbers on one side. So once you get the x on one side, get the numbers on the other side. So now we're going to subtract 30, subtract 30. So you should get negative 40 is equal to x. Okay, so are you guys getting this so far? Are you being active note takers and just trying the problems along with me as I go? Yeah.
I thought for on number 2 when it says minus x minus 5, I thought you were supposed to still factor that in, like so it'd be negative 1 and multiply that by x.
Yep, and I did. So this was like a negative 1 out front here.
Yeah.
And we multiplied into both things. That's what changed this sign. That's what made that a plus 5. Does it make sense? So yeah, same thing. I think you did it right. All right, so let's try the next one. So go ahead and try it along with me. Do your distributive property first, then look up here to see if you get the same thing. Okay, so did you guys get 15x minus 5 plus 5x minus 5 equals 7 plus 21x? You guys all get that? Good. I don't know why I did so many 5s. I'm the worst 5 writer ever. My 5s look like S's. Why did I do that to myself? All right. So we're going to combine our like terms. So we have 15 and positive 5x, so 15x plus 5x is 20x. Then I have negative 5 minus another 5 is negative 20, or not negative 20, negative 10, equals 7 plus 21x. So we're still good? All right, subtract 20x from both sides. So we get negative 10 equals 7 plus 1x. And then subtract the 7 from both sides. So we get negative 17 is equal to x. That's our answer. Yay, equations. Feeling good? All right, try number 4 and 5. So go and try them on your own. I'll pause it. Okay, so the first one we have 1/2 multiplied by 4x minus 2. So when I take that 1/2 in, half of 4 is 2. So I'm going to have 2x minus half of 2 is 1. So 2x minus 1. Plus 3x minus 15 equals 6 plus 6x. Did you guys all have that for the first step? All right, so then we combine our x's on the left-hand side. So we have a 2x and a 3x. Be careful that 2x, the sign in front of it is a plus 1. Or like a positive sign, I mean, not plus 1. So you're really taking the sign in front of it, not behind. A lot of people will mess it up and take the negative. So we get 5x minus 16 equals 6x plus 6. Subtract our 5x over and we get x. And then subtract the 16 and we should get negative 22. Did you guys all get negative 22? All right, good. If you did not get negative 22, do you see where your error was? So check this first step. So make sure you have 2x minus 1 plus 3x minus 15 equals 6 plus 6x. Yeah, one little error. Yep. Usually it's a little thing and it's always at the beginning. All right, so the next one, you should have 5x minus 5 plus 6x minus 21 equals 12x minus 30. Good so far? Combine your like terms, so you should get 11x minus 26 equals 12x minus 30. We subtract the 11x over and I get x. Man, I've been nice to you on these. I didn't give you any weird ones. They're all just 1x, aren't they? All right, and add the 30 over and I get 4. So x is equal to 4. Did we all get x equals 4? Awesome. Okay, so the next one's a little bit more complicated because now we have like 3/4, 1/2, 5/6. So you can put all these numbers as over 1 if you want to. And you could do them off to the side. So you could say like 3/4 times 4 over 1. Right? That ends up being 12 over 4, which is 3. So we get 3 minus 24 over 4, which is 6x, minus 5, plus, because negative 1/2 times a negative 4, what did you get here? Plus what? 2x, equals 5 minus 60 over 6, so 10x. So 3 minus 6x minus 5 plus 2x equals 5 minus 10x. Okay, that's not terribly difficult, but like I said before, some people do have fraction phobia, and they just freeze up when they see fractions, and they don't like it. So if you don't like it, we can work on these. All right, now we combine our like terms. So we were lucky because all of our fractions kind of went away. That doesn't always happen. So I get negative 4x minus 2 equals 5 minus 10x. And I'm going to add the 10x over so I get a positive number. Doesn't matter, but you could do either thing. So I get 6x minus 2 equals 5. I add the 2 over. So I get 6x equals 7. And my last step is I divide by the 6, so I get 7/6. I would leave it as an improper fraction. You do not have to write it as 1 1/6. Still feeling okay. All right, so let's do some weird ones. All right, now I saw several of you guys working ahead, which is fine. Like I said, you'd be active note takers, so you can try the problems along with me, and some of you guys are really good at this stuff, so you kind of went ahead. However, notice there's 2 different methods to this. So it says the long way and the short way. Okay, so the long way is to leave fractions in the entire time, which that's the way that you guys were doing it as I walked around, those of you that were working ahead. And I was just like, oh, it's so painful. There's like this really easy way of doing this. But Let's see. Okay, so the long way is to keep those all as fractions. So we're going to combine our x's. So let me rewrite my problem here. So let's say I want to add 3/4 to both sides. So I add 3/4 x, I add 3/4 x. Do you guys know what 1/2 plus 3/4 is? 1/4, is that what I heard? Yeah, I think 0.5, so negative 0.5 plus 0.75 would be 0.25. Okay, so I get positive 1/4 x equals 5/8. I then subtract 3/4 from both sides. So I get 1/4 x equals, how about 5/8 minus 3/4? 3/4 is 6/8. So I get negative 1/8. And then the last step is I have to divide by 1/4. So divide by 1/4, divide by 1/4. Dividing by 1/4 is the same as multiplying by what number? 4/1, right? So I'm dividing by 1/4, so I'm multiplying by 4/1. And then it reduces out, so I get negative 1/2 because it was 4/8. Okay, that probably did not make you feel very good. Even if you don't have fraction phobia, you were kind of like, bleh, I don't like writing this all out. Agreed? Here's the easiest way to do this. So one thing that students did last year, which I kind of like, is first they changed all the denominators so that they were the same. So they were like, oh, I'm going to make all these 8s. So 3/4, how can I write that with an 8 as my denominator?
6/8.
Yeah, it's 6/8. So I'm going to write it as 6/8 minus, how about 1/2? 4/8, right? 4/8 x equals 5/8 minus 6/8 x. Now from here it's going to be really easy because we know that equations are like teeter-totters. And whatever we do to one side, we have to do to the other side. So we want to keep our equation balanced. So I'm going to multiply through by one number. I'm going to multiply through by 8 on both the left hand and the right hand side. So sometimes I'm lazy and I do one big parenthesis like that. I'll go ahead and write 8 and 8. So you can see we're just keeping that equation balanced. So now when I multiply this 8 in, well, what's 8 times 6/8? What happens?
The 8's cancel each other.
Yeah, because it's 8/1, right? Those 8's go away, and it just becomes 6. So we get 6 minus 4x equals 5 minus 6x. Isn't that so much easier? Doesn't that just make you smile? You're like, oh, no more fractions, yay. All right, add the 6x over, we get 2x. So I have 6 plus 2x equals 5. Subtract the 6 over, I get negative 1. So x is equal to negative 1/2. Much easier. So you think we want to do this shortcut? Probably. So let's do the first step on this next one. So let's make them so they're all 12. I used to not do this. I used to just kind of keep it as the numbers they were, and then one of my students recommended that, and I was like, oh, that would be easier for you guys to change them all to 12, wouldn't it? Let's do that. So sometimes you guys have brilliant ideas. So we get all our common denominators, and then we clear the denominators by multiplying both sides of the equation through by 12. So we end up getting 6x minus 10 equals 7 minus 3x. And we just solve it out. So now that you guys are moving into geometry, we're in geometry now, no longer algebra, some of you guys are going to be able to do transition steps in your head. And this is a good skill to have. So what I'm going to do is I'm going to add the 3x over. What do I get on the left-hand side when I add the 3x over? 9x. In the same step, I'm going to add the 10 to the other side. So I have 9x, because this one's going to go over here, equals, and then I'm going to add the 10 over, 17. So my answer is x equals 17 divided by 9. Done. All right, you guys try number 9. So clear your fractions out. All right, so did you guys make it so that your denominators are all 36? So we have 11 over 36x minus 10 over 36 equals 18 over 36 minus 9x over 36. You can put the x on the side too, it doesn't matter. I kind of put it on the top there. Minus 8 over 36. So you should have 11x minus 10 equals 18 minus 9x minus 8 when you clear the fractions by multiplying through by 36. Everybody have that? Then we're going to combine on the right-hand side, so I'm going to get 10 minus 9x. And I'm going to start combining. So I'm going to add my 9x to the left side, I get 20x. I'm going to add the 10x or the 10 to the right side, I get 20. So we should get x equals 1. Did you guys all get x equals 1? Awesome. All right, and the last ones are ones that you can kind of try on your own, but let's kind of look at like number 11 or number 12. So it says, hint, distribute fractions first. It's a bit easier to understand. So I'll kind of explain what you could do without distributing, but most students kind of like distributing this like 5/7 and 3/5 first. Just think of it as over 1. So if I have 5/7 times 14 over 1, 5 times 14 is 70. So we get 70 over 7. What is 70 over 7? 10. So you could just write 10. Minus, then I get 5 over 7 times negative 21 over 1. So again, like, see how I could have just reduced out and made that 2 over 1 and I would have gotten my 10? What could I do here? So this would be negative 3 and 1, right? So don't I just get minus 15x? Does that make sense? And then over here I get, what's that going to be? 30 over 5. So 6x minus 3/5 times negative 15 minus 9. Good. I heard someone say 9. Was it you, Colin?
No.
Oh, Maya. I knew it was like that direction. All right, so I get 21x, and I'm going to add the 9 to the left-hand side. I get 19. So I think your answer should be 19 over 21. So on that one, you can distribute, which actually cleared the fractions for us anyway. The next one, it's not going to clear the fractions because I have negative 1/6 times 3. I'm still going to have a fraction. So then you would do that next step where you clear the fractions. Another thing that you can do on number 11, though, is you could notice that you have 7 and you have 5. So before you begin, you could have multiplied this by 35 and this by 35. And then your 35 and 5 would reduce to 7 and 1. So you could have just taken 21 into both sides. Does that make sense? Because 3 and 7. So it's a little tricky. So that's the way that I was saying. Most students don't like that way because they don't. They're like, what happened to the parentheses? Well, it's all being multiplied together. So you really just, when you multiply numbers, like if I do 2 times 3 times 4, I don't do 2 times 3 and 2 times 4. I just can just multiply by the first one. All right, so go ahead and try that, and we'll stop this video. So try number 12.